Assalamualaikum warahmatullahi wabarakatuh. Today I want to present to you about my group assignment, which is Kirchoff current law. Okay, the first one is we need to know the definition of Kirchoff current law. So Kirchoff current law is actually the sum of current that entering a node equal to the sum of current exit the node, which is mean sum of I in equal to sum of I out. Okay, this is the general equation of the Kirchoff current law only. Okay, so we look into this diagram. We can look here. I1, I2, and I3, which is entering the node, is equal to the current exit from the node, which is I4 and I5. So we can get this equation: I1 plus I2 plus I3 plus negative I4 plus negative I5 equal to 0. Okay. Okay, let's look into the next example, which is example 1. Okay, from this example, we have to find the Ix in the node B. Okay, so the first step is we have to determine the current which is the exit from the node A. Okay. The step is at node A, 0.5 ampere equal to 0.3 ampere plus I1. How do we get this equation? Okay, based on the general equation, which is I in equal to I out. So I in, which is 0.5 ampere, equal to 0.3 ampere, and I1. We consider the current exit from node A is I1. So I1 we can get is 0.2 ampere, which is by subtracting 0.5 by 0.3. So we can get the I1. Okay, the next step is at node B. We have to determine the Ix by looking the node B. At node B, the current entering the node is I1. I1 is here. Okay, the current entering the node is I1. So I1 equal to Ix plus 0.1 ampere. So we already got our I1 at our first equation, is I1 equal to 0.2 ampere. So we get here 0.2 ampere equal to 0.1 ampere plus Ix is here. So we, by using subtracting method, Ix equal to 0.1 ampere. So for the next example, we will explain the question for example 2. First, at node A, we will at node B. I'm sorry for the mistake. At node B, where the I1 is into the node, for the I2 and I3 is out from the node. So we will get the equation for I1 equal to I2 plus I3. For the example, for the loop ABC, we will get the 12 volt equal to the 4 I1 plus 6 I2. So we will get the equation for the loop ABC. We will get the 12 equal to 4 I1 plus 6 I2. For the next loop ABD, so ABD, we will get for 4 I1 plus 12 I3 equal to 12 volt. So after we will get the equation, we will use the calculator to get the answer. So what the answer for this? First, we will get for the 1, negative 1, 0 for the equation 1. For the next second equation, 4 I1 plus 6 I2 equal to 12 volt. For the third equation, we will get 4 I1 plus 12 I3 equal to 12 volt. So we will get the answer for the I1 is 1.5 ampere plus 1 for the I2 is for the I2 we get 1 ampere, and for the I3 we will get 0.5 ampere. So I think that's all for the example 2.
Okay, for the third question, okay, the question is here, we have to find the I1 and I2, I3, I4, I5. So therefore, to do that, we have to first find the R equivalent of the circuit, which is by this step. Okay, then we find the AC node here and then CF here. Okay. Okay, then the first step is we have to find the total resistance by calculating the R equivalent by doing this. This is a parallel circuit, so 1 over 60 plus 1 over 20 plus 1 over 30. Then we have to inverse it again. Therefore, we'll get 10 ohms by the CF loop, and therefore for the AC loop, do 1 over 2.4 plus 1 over 1.7, then we inverse it, so we'll get around 0.995 for the AC loop. Then the second step is we have to find the voltage across the AC and CF, because we can combine it together because the voltage varies here. So therefore we have to use V is equal to II. So VAC is equal to I total plus RAC. So it's equal to 12 times 1 is equal to 12 volts. So therefore for the VCF we have to use the same formula, V is equal to IR. So 12 ampere, we times that with 10 ohms, so we get 120 volts in total. Okay. Then for the third step, to find the current of each of the resistors here, each of the resistors, the I1, I2, I3, I4, I5, we have to use the Ohm's law. But to find I1 and I2, we have to use the value of the voltage is equivalent to 12 volts, because therefore, as I said before, the voltage varies here. So to find the resistance value between AC, we have to use 12 volts, and therefore to find the value of R between CF, we have to use 120 volts. So by using V is equal to IR, we can find the current value for all the resistors here. So V is equal to IR, VAC over R1 is equal to I1, so 12 over 2.4 is equal to 5 times. And then for the I2, VAC over R2, which is 12 over 1.7, we get 7 amps. And I3, 120 over 60, we get 2 amps. And I4, 120 over 20, we get 6 amps. And in final step, I5 is equal to 120 over 30, so 4 amps. So that's all for the solution. Thank you.